Now coming to the next question, question number 17, which diagram represents the structure of silicon dioxide? The first one is going to be a diamond, because why it is going to be a diamond? We can clearly see that one carbon is surrounded by four other carbons. The second one is going to be a graphite because it is existing in the form of a layers. And the third one is going to be an ionic compound because we can see the opposite symbols or plus and minus or as black and gray. So therefore it can be an ionic compound. And the fourth one is only the one which is one silicon is being surrounded with four other oxygens. Therefore, what it says, it can be a silicon oxide, silicon 4 oxide. And there's a question from March 2021, paper 22. Coming to the next question, question number 18. It is from November 2019, paper 23. Silicon oxide is a covalently bonded molecule. So silicon oxide is going to be nothing but what? A macromolecule, a very large molecule. Which of the statements are correct? Silicon atoms form four single bonds with silicon in silicon 4 oxide. So what will be the structure? Silicon is over here like this. So it forms four bonds with oxygen and oxygen over here. Why? Because silicon has what is this, a valency of 4, so it want to share it out 4 electrons, so it will be requiring it out 4 electrons, so that 4 electrons will be coming from oxygen. Similarly, what will happen is this oxygen having the what is this, in outermost electron shell, it has 6 electrons, so oxygen will be requiring it out 2. So therefore oxygen will be what is this, one oxygen will be forming a bond with and one silicon, and the same oxygen will be forming another bond with the silicon, so that it can get it out 2 electrons from the silicon. So in this way oxygen is also satisfied and silicon is also satisfied. So this is going to be a macromolecule, a very big large molecule. So once we come to the options, silicon atom forms four single bonds. Yes, that is correct. Oxygen atom forms two double bonds. No, it is not two double bonds. They form it out single bonds. So therefore that is wrong. And silicon 4 oxide has a high melting point. Yes, that is correct, because why it has a high melting point? You can see that one SiO4 has four bonds, four covalent bonds. So but silicon 4 oxide is a macromolecule. There are millions and millions of silicon 4 oxide. So therefore, in order to melt that, you have to break all the bonds, which is very difficult. So therefore, they will be having high melting point. That's correct. And silicon 4 oxide contain one silicon atom and four oxygen atoms. On the face value, it looks like that. But the thing is, as such, again, in the beginning only, we said that this is a macromolecule. So therefore, individually, SiO4 cannot exist. So therefore, SiO4 is going to be a large macromolecule, which exists in the form of like these chains. That's the reason it is a macromolecule, and therefore it does not can be considered as one silicon atom and four oxygen atoms. So therefore only 1 and 3 is correct. So option B is correct. Coming to the next question, question number 19. This is from specimen paper. So which statement about the metals is not correct? So see, not has been highlighted. So very carefully you have to see. They conduct electricity because of delocalized electrons that move throughout the metal. Yes, that's correct. So electricity is only because of this delocalized electrons. They consist of layers of atoms that can slide over one another. Yes, because when we see the metals are existing, all the solids, then they will be existing in the form of layers like this. So obviously that is also correct. They are layers of atoms. Then they have a giant lattice of oppositively charged ions. So you can see that option 3 and option 4, C and D, they differ by oppositively charged ions and positive ions. So basically it is not oppositively charged ions because metal is a neutral atom. So therefore what is the thing case is, they will be always nothing but what, positive ions, not oppositively charged. If at all it is we are talking about ionic compounds, then we have to do it about what is this, oppositively charged ions. But we are not talking about ionic things, we are talking about the metals. So therefore option C is wrong. Option C is wrong. So option, what is this, D is correct. So what is he asking? But in the question he is asking what is this, which option is wrong? So C option is wrong and A, B, D are correct. So that's going to be the answer. Coming to the next question, question number 20, he's asking which diagram best represents the structure of substance that is good conductor of electricity. The first one is going to be diamond. We know that diamond is not the good conductor of electricity because we can see that one carbon is associated with what is this, four other carbons. It's a tightly packed one, giant molecule. So it is not a good conductor of electricity. Next one is nothing but what, a covalent compound. A covalent compound cannot be a what is this, good conductor of electricity. And the third one is an ionic compound. How do I know it's an ionic compound? You can see that positive and negative charges, but it's going to be a solid. because if at all in an aqueous solution or a molten state, ionic compound may be what is this conducting electricity, because these positive and negative ions are free to move. But over here in a solid, they are not free to move, so therefore they are not what is this conduct electricity. Now finally, just now in the previous question we have done that it is looking like a metal. So metal, because there are layers, so metals and some other foreign objects are there. So this is nothing but what? An alloy. So we know that alloys are good conductors of electricity because of the metal. So therefore, D, option D is going to be the answer. Coming to the next question, question number 21. Cesium is a metal in group 1 of the periodic table. Which description of the bonding in cesium is correct? Electrostatic attraction between oppositively charged ions. Oppositively charged ions is in what? Ionic bonds or ionic compounds. But we have nothing but what? It's a metal. So therefore, first option is going to be wrong. Electrostatic attraction between positive metal ions and the mobile electrons. Yes, because we know that in the previous question also we have done that. In a metal, all the positive ions are going to be arranged in what is this layers, and in between them there are electrons. In between them there are free localized electrons. So when I zoom it and check it out, you can see that these electrons are getting attracted towards the positive ions. So therefore, what is this electrostatic attraction is there between positive metal ions and mobile electrons. So therefore, the first option is totally wrong. The second option is correct. What about the third and fourth? Neighboring metal atoms have sharing pair of electrons. They don't share electrons. The metal atoms will be what is this? Donating electrons, because they form ionic bonds. Ionic bond is formed by donation of electrons. Strong attractive forces between the atoms. Yes, strong attractive forces is there, but between the atoms not. Between the positive ions and the free localized electrons. So therefore, option D is also wrong. So only option B is correct. Now coming to question number 22, a compound has a formula XF2 and has a relative mass of 70. What is the element X? So X plus 2 times of fluorine equals to 70. So from the periodic table given in the question paper, fluorine is going to be 19 equals to 70. X plus 38 equals to 70. So X equals to 70 minus 38, which is going to be 32. So if at all you can memorize it, or 32 is about nothing but what? Sulfur. It's not either gallium, germanium or other thing. So we can just choose the answer as sulfur, or you can check in the periodic table. Sulfur has a mass of 32. That's going to be. Coming to the next question, question number 23. He is asking the element sulfur is found in the number of different minerals. Which mineral contains the greatest percentage of sulfur? So we are going to find it out, the amount of sulfur in every, what is this, option. So first of all, if at all I go for option A, it is sulfur is nothing but 32 upon barium sulfate. So from the periodic table, I'm directly writing it out. 137 plus 32 plus oxygen is 16, 16 times 4. Simplify that, I'm directly writing again, so 13.7%. Now I go for B. So PBS, again sulfur is 32 upon PB is nothing but what? 207 plus 32, which gives me nothing but how much? 13.3%. Now option C, when I do that one, it is gypsum. So sulfur is only 132 upon calcium is 40 plus sulfur is 132 plus 16 times 4. Simplify that, you should be able to get 25.5%. And finally option D, pyrite, which is FeS2, S2, 32 times 2 is 64 divided by Fe is 56 plus 64. That's going to be nothing but how much? 53.3%. So we can see that clearly it is highest in option B. So A, B, C are wrong options. To the next question, question number 24. The formula of two compounds of MnO2 and KMnO4 is there. In these two compounds, the oxidation state of potassium is 1 and oxygen is -2. Write down the oxidation states of manganese. So first of all, I take MnO2. So it's a neutral compound. So total what is this oxidation state has to be 0. Manganese we don't know, let it be X. Oxygen he has given it as -2 equals to 0. So X minus 4 equals to 0. So X equals to 4. So manganese should be having 4. So option A and option B are totally wrong. So I'm only left over with nothing but what? Option C and D. Now what is the thing for KMnO4? We take for KMnO4. Potassium is +1 and manganese we don't know X, and oxygen is -2. 4 more times -2. Again it is a neutral compound, 0. So 1 plus X minus 8 equals to 0. X minus 7 equals to 0. So X equals to 7. So again we can see that option C is wrong. So only option D is correct. That's going to be the answer. Now coming to the next question, question number 25. The formula for hydrocarbon of CXHY The equation for its complete combustion is given. Write down the values of X and Y. So we can see that it is 5 carbons over there. So X also has to be 5 carbons. So when X is 5 carbons, obviously option C and option D are wrong. So I have to answer only option A and B. Then Y. Y is nothing but what? It is dealing with hydrogen. So how many hydrogens are over here? Y. And how many hydrogens are over here? 12. 6 times 2 is 12. So option B is correct and option A is going to be the wrong option. So that's going to be the answer. Coming to the next question, question number 26. This is from June 2021, paper 21. 2.56 grams of metal oxide MO2 is reduced to 1.92 grams of metal. So what is going to be the equation? So equation, I'm going to write it out over here. So MO2 gives rise to M. Plus obviously oxygen or carbon dioxide is later, but the thing is we can see that the mole ratio, if at all I see that this is 1 over here and it is also over here 1, so the mole ratio has to be the same. So number of moles of metal oxide should be equal to the number of moles of the metal. So number of moles of metal oxide is nothing but what? It's, what am I going to do? It's mass upon mr equals to mass upon mr. So mass of the MO2, mass of MO2, how much he has given it out? 2.56 upon MR of MO2. We don't know. So let the mass of M is X and there are two oxygens, 2 times 16 equals to 1.92 upon mass of M is again MR of M we thought it as X. So mass upon mr equals to mass upon mr for both, because the mole ratio is going to be the same, 1:1. So the both has to be the same, mass upon mr. So mass of MO2 is 2.56 and mass of M is 1.92. Their MRs are X plus 32 and X. So from here, what am I going to get that one? 2.56 upon X plus 32 equals to 1.92 upon X. Then we do the cross multiplication, or before cross multiplication, what am I going to do it is I'm going to multiply by 100 on both sides. So it will take away the risk of this decimals. X plus 32 equals to 192 upon X. Do the cross multiplication. So what does that becomes now is 256x equals to 192x plus 192 times 32. 192 times 32 is 6144. Now 256x minus 192x equals to 6144. So when I might subtract it out, it becomes 4 and 64. 64x equals to 6144, and I get it out, x equals to 6144 divided by 64 is 96. So which is that option? Option B. Coming to the next question. Next question is question number 27 from June 2021, paper 21, question number 9. So what is that? Chlorine gas will react with iron metal, exactly 21.3 grams of chlorine. So chlorine Cl2, which is 21.3 grams, will be reacting with Fe, which is 11.2 grams. How many iron atoms react with 30 molecules of chlorine? So we need to find 30 molecules of chlorine. So for finding it out 30 molecules of chlorine, because we know that molecules is proportional to moles. Molecules, number of molecules is proportional to nothing but what? Moles. Why is that? 1 mole will be equals to always Avogadro number of molecules, 6.023 times 10 to the power of 23 molecules. So they are proportional to each other. So what am I going to find it out? I am going to find it out how many moles are there in this chlorine. So which is 21.3 divided by mr. mr of chlorine is 71, not 35.5. 35.5 times 2 is nothing but what? 71. So how many moles is that? 0.3. Similarly, I need to calculate how many moles is that for iron 2. 11.2 divided by 56, which is going to be nothing but what? 0.2. So what can I do that? I quickly add a page so that it will be much more beneficial or easy to do that. So what can I get from there? 0.3 moles of chlorine will be requiring it out 0.2 moles of iron. So chlorine and iron. Now, because we know that moles and molecules are related to each other, so 30 molecules of chlorine. 30 molecules of chlorine will require how much? So it does becomes 30 times 0.2 divided by 0.3, which is going to be 20. So which is that option? Option C is going to be the answer. Coming to the next question, question number 28 from June 2019, paper 22, question number 8. So to 25.0 centimeter cube of 0.100 mole per decimeter cube, aqueous sodium hydroxide is neutralized by 24.6 centimeter cube of dilute sulfuric acid. So what am I going to do? First of all, I'm going to write the balanced equation. 2NaOH plus H2SO4 gives rise to Na2SO4 plus 2H2O. So we can see that this is going to be the standard, what is this, balanced equation. So for moles ratio for is NaOH and H2SO4, if at all I find the ratio, it is 2:1, 2 moles. So I have to find it out the moles for NaOH2. So how do I find it out moles for NaOH? So he has given it out the concentration is 0.1 in decimeter cube. So volume also will be converting into decimeter cube. So 25 centimeter cube can be converted into decimeter cube as 0.025 dm cube. So dm cube. So we know that moles equals to CV. So multiply 0.1 times 0.025. So what does that become? 0.0025 moles. That's going to be for NaOH. Now for H2SO4, if NaOH moles is 0.0025, what will be the moles of nothing but what? H2SO4? It will be 0.0025 times 1 divided by 2. So number of moles of H2SO4. Moles of H2SO4 equals to 0.0025 divided by 2 is 0.00125. Now, again, we know that N equals to CV. So, N is 0.00125 equals to concentration of H2SO4. What is the concentration of H2SO4? We don't know. What is the volume of H2SO4? 24.6 cm cube. So, 0.0246 dm cube. So, concentration we have to find it out, and volume is 0.0296. So from there, concentration equal to 0.00125 divided by 0.0296, which will be 0.0508, which is going to be the answer. Option A is going to be the answer. Coming to the next question, question number 29. Gas syringe X contains 100 centimeter cube of hydrogen bromide gas, and gas syringe Y contains 100 centimeter cube of carbon dioxide gas. So what am I going to do with it? I am going to draw the gas syringe of for what it says. Let me draw that one, gas syringe. Approximately in this shape. Similarly, I'll be drawing a gas syringe for carbon dioxide too. I can draw it out in a proper way. I'm just drawing a rough diagram. Gas syringe of for carbon dioxide and for hydrogen bromide. So what is that? Both are having 100 centimeter cube. So 100 centimeter cube, 100 centimeter cube. But what is the one is nothing but what? Hydrogen bromide, and another one is nothing but what? Carbon dioxide. Carbon dioxide. Now both are having same volume. So they are having same volume. If they are having same volume, the first and foremost condition is nothing but what? They will be having same moles. Why do they have same moles? Because V equals to 24N. So therefore, if the same volumes are there, same moles also will be there. If they are having same moles, it indicates that they will be having same molecules. Why do they have same molecules? Because 1 mole equals to nothing but what? 6.023 times 10 to the power of 23 molecules. So therefore, because of that Avogadro number, they will be having same molecules. Now, but when the thing is, these are the things, they have same moles and same molecules. Now, coming to the options, which statement is correct? The mass of HBr is less than mass of carbon dioxide. Now the mass will be different. Why? Because moles is equal to mass upon Mr. So Mr for hydrogen bromide is going to be nothing but what? 81. And moles, if at all it is same, you can see that. And over here, mass upon Mr of carbon dioxide is nothing but what? 44, which will be totally different. So therefore, masses will be compulsorily surely be different. So therefore, option A is going to be wrong option. Now, number of molecules, just now we considered that number of molecules are same, so therefore option B is correct. What about C and D? The gas syringe X contains more number of atoms than that of gas syringe Y. This is X and Y. Is that correct? We can say that HBr has 2 atoms and CO2 will be having 3 atoms. So we can see that every time HBr has only 2 atoms, whereas CO2 will be having 3 atoms. So obviously Y will be having more number of atoms than that of X. So option C is also wrong. Now coming to option D, why it is wrong? number of moles of HBr is more than the number of moles of carbon dioxide. Just now we have told that both will be having same moles. So option D is also wrong. So only option B is correct. That's going to be the answer. So coming to the next question, question number 30 from March 2019, paper 22, question number 19. Calcium carbonate reacts with dilute hydrochloric acid according to this equation. So let me write that equation. CaCO3 plus 2HCl gives rise to CaCl2 plus CO2 plus H2O. Now, what is that? He has given 10 grams of calcium carbonate. So I am going to find the moles of calcium carbonate. 10 divided by Mr, which is 100. 10 divided by 1 is nothing but 0.1. So now I'll be calculating for that of hydrochloric acid also. So N equals to Cv. So concentration is nothing but how much he has given it out, 1 mole per dm cube, and volume is 100 cm cube. So convert into dm cube, 0.1 dm cube. So concentration of HCl is nothing but what, 0.1. Now the mole ratio is nothing but what, 1:2 for calcium carbonate and HCl. So I have 0.1. So how much of that is required for calcium carbonate? Only 0.05. But how much do I have? I have 0.1. So obviously nothing but what, calcium carbonate is in excess. Calcium carbonate is in excess. Now the limiting one will be our, what is this, hydrochloric acid is going to be the limiting reagent. So HCl will be deciding how much of carbon dioxide is going to be released. So mole ratio of HCl is nothing but what, and that of carbon dioxide is 2:1. So number of moles of HCl, we know that it is 0.1. So number of moles of carbon dioxide will be 0.1 divided by 2, which is 0.05. But I want to know the volume. So volume of carbon dioxide. So volume of carbon dioxide, we know that but is 24N. So 24 times 0.05, which is going to be nothing but what, 1.2. So volume of carbon dioxide is nothing but what, 1.2. But how much he has been given over here? Same. So first option is going to be correct. Now we will be calculating the mass of carbon dioxide also. So for calculating the mass of carbon dioxide, we have to calculate the mass of carbon dioxide. So how do I calculate the mass of carbon dioxide? Mass equals to N times Mr. So N is nothing but what, 0.05 times Mr of carbon dioxide is 44, which gives me 2.2 grams. But how much he has been given over here? What is this? 4.8 grams. So carbon dioxide is wrong. Mass of calcium chloride will be, the mole will be again 0.05. Why the mole is 0.05? We can see that for HCl and calcium chloride, the mole ratio is going to be again 2:1. So it is going to be the same 0.05 times Mr of calcium chloride. Mr of calcium chloride is 111. Simplify that one. What do I get it out? I get 5.55. 5.55 grams. And how much has he given? 5.6, rounded off. So second option is correct. No calcium carbonate is left. We know that calcium carbonate was excess, but he says that no calcium carbonate is left. So option 4 is also wrong. Option 3 is also wrong. So only option 1 and 2 are correct. So A is going to be the answer. Coming to the next question, question number 31 from March 2019, paper 22, question number 8. An oxide of nitrogen has a composition of, what is this, 30.4%, and oxygen is 69.6%. The relative molecular mass is 92. What is the molecular formula? So first of all, we have to calculate the empirical formula. So for that, we have to calculate N. So how do I calculate N? Divide by their atomic mass, which is divided by 14 for nitrogen and 16 for oxygen. So when do I get that one is 2.17 and 4.35. So, but we have to divide again with the smallest number. So divide by 2.17 and 2.17. So it becomes 1 and 2. So 1:2. So what will be the empirical formula becomes? Empirical formula is NO2. So empirical formula mass will be equals to 14 plus oxygen is 32, which is nothing but what, 46. Now the molecular formula equals to nothing but what, X times empirical formula. So over here it was 92 equals to X times 46. So what is that integer? X equals to 2. So what's going to be the empirical now? Empirical formula is NO2. So we have to know the molecular formula, means we have to multiply by 2. So when NO2 is going to be multiplied by 2, so what am I going to get it out? N2O4. So when I get that answer N2O4, check it out. Which option is that one? Which is option D. That's going to be the answer. So now June 2020, paper 21, question number 9, the question number 32, the last question for this part 2. The remaining next 16 questions will be done in part 3. So the Haber process is a reversible reaction. The reaction has a 30% yield of ammonia. So only 30% is being given. Which volume of ammonia gas measured at room temperature and pressure is obtained by 0.75 moles of hydrogen? So hydrogen and ammonia mole ratio, we find it as 3:2 ratio. So hydrogen is 0.75. So how much is that? 0.75 times 2 upon 3. That's going to be nothing but what? 0.5. So the moles of ammonia is going to be 0.5. Now we know that volume equals to n times 24. So therefore 0.5 times 24, which is going to be 12 dm cube. So volume of ammonia is going to be 12 dm cube, but that is 30% of the volume. So 12 times 30%, which gives me 3.6 dm cube of ammonia. So this 3.6 dm cube of ammonia, when convert into cm cube, so it will become 3600 cm cube of ammonia. So the answer is going to be 3600 cm cube. So option A is going to be the answer.